All right, polynomial boot camp. We're gonna hit you hard with the basics right here and hopefully get us prepared for the second semester. Polynomial though, what is a polynomial? A polynomial is basically when we're adding or subtracting a bunch of different terms together. So poly means many, nomials means name or terms. So for example, I'm going to start with this one. We have one addition sign. We're taking the 27x squared and adding y squared. That is two separate terms that are getting added together. 27x squared is one term, y squared is the second term, and so that is a polynomial because it's many terms. We specifically call this one a binomial because bi means two, and we have two terms. This particular one, we don't have anything being added or subtracted, so this is just one term, which we call a monomial. Mono means one, right? So one term is a monomial. Two terms is a binomial. This one has three terms. We have 3x to the fifth, 2x to the third, and 7x. So three terms, which we call that a trinomial. Right? Tri for three. And then anything with more than three terms, we usually just call a polynomial. So this one has 1, 2, 3, 4 different terms. So we just call it a polynomial with 4 terms. You could say this is a polynomial with 2 terms. We just call it a binomial. Polynomial with 3 terms, call it a trinomial. And a polynomial with only 1 term is just a monomial. We also specify a polynomial by the degree of the polynomial. And in this case, what we mean by degree is the greatest exponent. So whatever the largest exponent is in the polynomial, that is the degree of the polynomial. So for example, this is 3x to the first power. This is 9x to the third power. And then this one doesn't have a variable. So the largest exponent was right there, right, which is a 3. So this would be a third degree. And then this would be a third degree trinomial because there are 3 terms. This next one we have to the 5th power, to the 1st power, and then to the 9th power. So this would be a 9th degree because the largest exponent was 9. And then this one, it might look like there's no exponent, but 5t is really 5t to the 1st power. So this would be a 1st degree polynomial. Or more specifically, because it's 2 terms, we could say a 1st degree binomial. And then this last one, it's 1 term, it's a monomial. Is the degree -9 or is it 5? We look at the exponent, so since the exponent is 5, this would be a 5th degree polynomial, or a 5th degree monomial because it's 1 term. All right, so that's some vocabulary. Now we're going to move on to our main focus of this boot camp session, which is adding and subtracting polynomials. The good news is adding polynomials is really just combining like terms, which is something that we've all done before. So again, sum means add. So if we're asked to find the sum of 2 polynomials, that means we're going to add them. And sometimes we'll be given this function notation, which looks a little scary, but I promise you it's not. If we're given f plus g of x, well, that just means I take the function f of x and add it to the function g of x. Okay, what does that mean? Well, if I am told that f of x is 2x plus 3, and then I know that g of x is 3x minus 1. Well, if I'm asked to do f plus g, that just means I'm going to add this function, 2x plus 3, to this function, 3x minus 1. Well, if I'm adding those together, I know that 2x and 3x are like terms. So I can add 2x and 3x, which gives me 5x. And then I can take the other like terms, positive 3 and negative 1, right? They're just regular numbers or constants. So we can go ahead and combine those, which positive 3 plus a negative 1 is positive 2. So if we add the two functions together, we get 5x plus 2. All right, sometimes you'll be given the problem in a more simplified form, which honestly, most of our problems are going to be in the simplified form, where we just have the two polynomials in parentheses, and we're told to add them together. So when we have something like this, because it's addition, all we're going to do is combine like terms. So I'm going to find my x's, right? So 2x and 3x, they add up to make 5x. And then I'm going to find my constants. So I take my 3 and negative 1 and combine those to get positive 2. So 5x plus 2. Hey, that's the same problem we did over there. Look at that. Side note, I like to use sometimes like lines. If I don't have different colors, maybe I'll do one line for one pair of like terms, and then maybe I'll do 2 lines to show that these ones are like terms and they go together. Some people like to use shapes, right? You could do circles for one set of like terms and maybe triangles for the other set of like terms. Just find whatever works best for you. You'll notice in the videos, I usually just do the underline to show the terms that go together. All right, so find h plus g of x. That just means add this function with this function. So I know that negative 2x can go with 4x, which gives me 2x, right? Negative 2 plus 4 is 2, so 2x. And then negative 1 and negative 3. Make sure to always include the sign in front, right? So I have negative 1 added with negative 3, which gives me negative 4. So when we add those polynomials, we get 2x minus 4. Okay, likewise here, if it's set up like this in parentheses, because we're just adding, we're finding like terms. Why don't you go ahead and try this one? What do I get when I add those two binomials or polynomials together? Nice job, not bad for your first try, right? 4n squared goes with 3n squared, which makes 7n squared. Notice that we don't add the exponents when we combine like terms. They stay the same exponent, right? So it still stayed squared. And then 2n, oh, look at that. I didn't have anything to combine the 2n with, right? There is no like term for that. So that's just going to go by itself. And then negative 5 is a constant, right? No variable attached to it, which I don't have any other constants, so that's just going to stay minus 5. So when we combine those two binomials together, we get the trinomial 7n squared plus 2n minus 5. All right, 2 more examples with addition. We're going to add the two together, right? So I'm looking for like terms. Negative 2x squared plus 4x squared, which would be 2x squared. Negative 3x minus 4x. Negative 3 and a negative 4 make negative 7x. And then finally I've got negative 1, positive 2. Those are like terms. They can go together. And if I add those, I get positive 1. All right, this next example, we have something to the third power. Do I have anything else to the third power? I don't, right? So it does not have any like terms. So I'm just going to put that first. And typically we do put the largest exponent first. So if the exponents were out of order, right, if n to the third had been over here, we would still put that first in our final simplified polynomial. But then I go to the next exponent, which was n squared. I'm gonna go ahead and circle these since I have a lot of terms. I'm gonna look for something else with n squared. There we go, I've got 3n squared, which means if I add those together, I have a total of 7n squared. And then I've got n, I'll change colors, there we go. N can go with 5n, right? And n is the same as 1n, so if we add 1 and 5, we get 6. And then I've got my constant, -1. That can go with this constant of +7, and -1 plus 7 is 6. So when I combine all those together, I get n to the third plus 7n squared plus 6n plus 6. And I can't combine any of these together because they are not like terms. We've already simplified it as far as we can go. All right, so that was adding. The second part of boot camp today is subtracting, which subtracting is a little bit tougher. There's just one extra step, so it's not too bad. But we just got to make sure we're careful. So if you're asked to find the difference between two polynomials, right, difference, that just means subtract. Same notation if we have f minus g of x. That means we're going to write our function f of x first and then subtract g of x from it. Right, so my f of x is 2x plus 3, so I'm going to write that first. I'm going to actually put it back into parentheses, kind of like our simplified version. But then I'm going to subtract g. So I'm going to subtract, and then I'm going to put g of x in parentheses as well, which is 3x minus 1. And now it looks a lot like addition. However, we have to be extra careful because we have to subtract everything from the second function. So what I would recommend is distributing this negative as a reminder that we have to subtract both of those. So if we distribute the negative, this becomes minus 3x. And if we distribute the negative, negative times negative is positive, so we get plus 1. So once I've distributed that negative, I'm done with that, and I am back to combining like terms. So I can combine 2x with negative 3x, which would be negative 1x. And then I can combine positive 3 with positive 1, which gives me 4. All right, again, so if we put that in the more simplified form, when I see that I have subtraction, I'm going to distribute my negative, which will change the 3x to minus 3x. And then we're going to distribute the negative, because if we subtract negative 1, negative times negative means we're really going to add 1. So it becomes plus 1. The other thing you could do if you want is you could rewrite this first binomial. You could write 2x plus 3 if you want it all on the same line. Otherwise, you could do it like I did here and just leave it where it was. But at this point, I can combine like terms. 2x and negative 3x is negative x. Positive 3 plus 1 is positive 4. All right, and so these problems were actually the same problem, just presented a little bit differently. All right, let's practice that. If I want to do h minus g of n, which function do I need to put first? All right, I need to put h. So h of n was n minus 1. That will go first. And then I'm going to subtract g of n, which is 3n minus 1. And again, the first thing we need to make sure we do is distribute this negative. Otherwise, I can promise what will end up happening is people will do -1 minus 1 and put -2 at the end. And you're going to see that the end is actually not minus 2, because when we distribute that negative, we get minus 3n, but this actually becomes plus 1, because negative times a negative is a positive. And so if I rewrite this first binomial, my like terms now give me a negative 2n. And then what's negative 1 plus 1? Well, it is not 2, right? It is 0. So negative 1 plus 1 is 0. I don't need to put a 0 there. I can just say that when I simplified it, my final simplified polynomial is just negative 2n. All right, let's have you go ahead and try this subtraction problem. Okay, so hopefully you remembered to distribute the negative, which will give you negative 2x, and then two negatives make positive, so plus 5. 4x minus 2x is 2x, and 5 plus 5 is 10. So that simplifies to 2x plus 10. All right, last two problems, and then we're done with boot camp for today. Again, we're going to subtract. We're going to start with f, so I'm going to put that function first. And then subtract. Then I'm going to put the g function, g of x, going to put that next. This has more terms, but it doesn't change the process. It's still the same process. Trust the process. All right, so subtraction. If it was addition, I wouldn't have to do anything. I could just combine like terms. But because it's subtraction, I have to make sure I subtract this entire function. So I'm going to distribute the negative. Negative and negative make a positive 3x squared. Negative and negative make a positive 4x. And then negative times a positive will make this a negative 3. So I rewrite that second function. And now I can combine like terms. Negative 3x squared plus 3x squared. Negative 3 plus 3 is 0. So we have no x squareds. I do not need to write 0x squared because there aren't any. I can just not put anything. But then we have 1x plus 4x, which would be 5x. And then finally, negative 9 and negative 3, which combine to make negative 12. So when we subtract those polynomials, we get 5x minus 12. All right, finally, this last one. Again, I notice subtraction, so I'm going to distribute my negative, which gives me negative 4x squared. Negative times negative is positive 3x, and negative times positive is negative 2. All right, so I'm done with those, and now I can combine like terms. My largest exponent is to the third power, so this is going to be a third degree polynomial. And when I look for anything else to the third power, I don't have anything else, so that's just going to go by itself. Then I look for the second power, which I have negative 5x squared and negative 4x squared. And if I have a negative 5 and combine that with a negative 4, that's a negative 9x squared. And then I look for my x's, my x to the first power. I've got negative 1x and positive 3x. Negative 1 plus 3 is 2. So that means we have 2x. And then finally, I've got positive 7 and negative 2. And if I add those together, 7 minus 2 is 5. All right, day 1 of boot camp done. See you tomorrow.